So let's look at the case when n equals 0. So we're assuming that f is not even and has no branch cuts. Then we use this contour. And we consider this contour integral. So we want the n equals 0 case, so I just the integral of f of x, where f is not even and has no branch cuts. And we instead evaluate, sorry, it should be to z, the contour integral of f of z times log z. So let's just see where this gets us. So integral along here just gives us I1. Then we've got the limit as r goes to infinity of 0 to infinity of f of r e to I theta log r e to I theta I r e to I theta d theta, which we're going to, if you know what f of x is, then you can show that this hopefully will go to 0. The important bit is what happens when we integrate back along here. So we've got the integral from infinity to 0 along here. Z is equal to x times e to the I 2 pi. So dz is equal to dx. F of z doesn't have any branch cuts, so we can just write it as f of x. But log of z is log of x plus I 2 pi dx. Then we have to consider, as usual, the integral around here from 3 pi by 2 to pi by 2 of f of and again show that this hopefully will go to 0, but obviously it depends on each problem. It doesn't always go to 0. There's some cases where you actually get a finite answer. So you need to check each time. So assuming these two things go to 0, what do we have left? Well, we've got I1. Now with this, we can swap the limits and get a minus sign. But look what we have when we expand the brackets. F of x times log x. Well, that is precisely I1. Okay, so we end up with a minus I1. So the I1s cancel. And I2 pi times f of x is just 2 pi I times I0, which is the thing we want. So we end up with 2 pi I times I0. Now all of this, of course, is equal to 2 pi I times the sum of the residues of, and remember to get this right, it's not f of x, it's f of x times log x. So it's f of z times log z evaluated at the poles. So as these I1s cancel, we end up with the final result that I0 is equal to minus the sum of the residues of f of z log z. I'm going to go on about this a bit later. Just remember that f of x is very likely to be real in your problem. So you should get a real answer, which means that if you like, you could write this as the real part of the sum of the residues. You should end up with the sum of the residues should be real anyway. But if you want to make life easier and not want to bother calculating all the imaginary parts and checking that they all cancel out, you can just go ahead and calculate the real parts because you expect to get a real integral in the end, a real answer in the end for the integral.